Hi guys, this is Jonathan Lambert with Maths and Stats, and in this video, another video in our series of videos in non-parametric correlation analysis, we're going to concentrate on the calculation of the correlation between a ranked ordinal variable and a variable measured on an interval ratio scale. And like previous videos in this series of videos, I have mentioned the text by Weary, so it's by Weary. It's called Contributions to correlation analysis, and in that particular text, Weary develops a number of formulas. What he has labeled are called the missing formula for variables that are measured on different scales for all the combinations of variables. But in particular, he provides a formula for ranked ordinal variables versus interval variables. And what does that formula actually look like? It says that the correlation between a ranked ordinal variable and an interval variable, or subscript Ri, is simply equal to, it's the sum of the cross products of the ranks times the scores on the interval variable, divided by the number of paired observations that we have in the data set in the sample, minus the number of paired observations plus 1, divided by 2, so it's half that particular value, times 1 over the mean of the observations on the interval variable, and that's all divided by it's n squared, the number of paired observations, minus 1 divided by 12. Okay, it's the square root of that particular value times 1 over, I suppose it's times 1 over excuse me, it's not actually 1 over, it's actually times the standard deviation of the y's. So let's actually just have a look at that there. It's times the standard deviations of the y's. So it's times sy. So we get the square root of n squared minus 1 all over 12, and then that's multiplied by the standard deviation of the y's. So in this particular example, let's consider a numerical example. Let's say, for argument's sake, that we took a sample of professional golfers. Okay, so let's just sample some professional golfers. And then professional golfers that we sampled, we asked them their world rankings. So we have their world rankings down the first column here. The first golfer that was randomly sampled was ranked second. The next golfer was ranked number 1, the next third, the next fourth, and the next fifth, for argument's sake. And then what we also kept track of was the salary associated with those particular golfers. So we have their salaries. The first golfer earned 3.5 million. The next golfer, who was ranked number 1, earned 6.7 million. The next one, 4.2 million. The next one, 1.7 million. And then the next golfer, who was ranked 5th, earned 2.2 million. And what we want to try to assess here is if there's a relationship, or the strength of relationship, between the world ranking and the salary that the golfer achieved over that particular year. So what we need to calculate is, first of all, we need to calculate the sum of the ranks times the value, the score on the interval variable. So don't forget, here's the ranked variable and here's the interval variable y. So we need to calculate Ry. Okay, so we're going to have to do that. We're also going to have to keep track of the number of paired observations. In this case, it's straightforward enough. The number of paired observations is n is equal to 5. Okay? We're also going to have to calculate the mean of the y variable. So we'll need to calculate the mean of the y variable. Actually, I had that as 1 over that. That shouldn't be 1 over that. That should be just times the mean of the y variable. So it's n plus 1 over 2 multiplied by the mean of the y variable. So we have to calculate the mean of the y variable. Okay. We also have to calculate the standard deviation of the y variable, of the interval variable, and we need this sum of Ry of the ranks. Okay. So we know n. Let's calculate the mean of the y variable first of all. So what we have here is we're going to sum up these values: 3.5 plus 6.7 plus 4.2 plus 1.7 plus 2.2 gives us a total score here on the salary of 18.3. We need the average of that, so we're going to divide that by 5, the sample size. So it's 18.3 divided by 5 gives us an average of 3.6.